Welcome to Chamford. I'm Jessal, and here we discuss all things 3D printing. I have a problem to solve. I do every video, but for this video, I have to make a magnetic connector for my heated vest. And let me take a step back and give you some context. So the home office that I use for my day job, as well as the production work for this YouTube channel, is located in my basement. And it gets really cold down here. Even in the summer, it's pretty cold. And not too long ago, I bought a heated vest that runs off of a 5-volt USB power. It's too big to fit on my table, so I'll just flash it on the screen here. Anyway, I've been using it for a couple of months now, and instead of using a battery bank, I just keep it plugged into the USB port of my desk. And it works great, except that I keep forgetting to unplug it when I stand up, so I'm afraid I'm gonna break the vest one of these days, or the USB port, or both. So I better fix the issue now before it's too late. And the solution that I thought of is using magnets. There's nothing new or challenging about the thing that I'm building, so I suspect this video is going to be pretty short. One other thing though, I've always thought the performance of this vest to be a little underwhelming. It gets warm if I wear a jacket over it, but with the vest alone, I barely notice the difference between not wearing it versus wearing it. So earlier today, I took this meter and measured the power usage of the vest. And it turns out it only uses 4 watts of power, which is very confusing because the manual specifically said that I need 10 watts of power. So I switched to a different power source and kept increasing the voltage. At 7.4 volt, it was getting decently warm, and at 8.2 volt, it was getting pretty hot. And I was a little scared to push it any further, so I stopped there. So, as a result, I'm going to be using this 7.4 volt power supply as opposed to using the existing USB port at my desk. Alright, let's jump into the project. Right, we're on printables and I found this model. Seems really popular with 2500 downloads. And it's almost exactly what I want for my connector, except a couple missing features. One is that there's no support for my size of magnets. I have 6 by 3.6, which seems like an odd size, but that's what I have. So I'm going to have to make an adjustment there. And the second thing is, I don't want my cables to take a 90-degree turn and stick out the side. I want my cables to go straight down. Apparently they do have the straight model for the female version, but not the male connector. So I'm going to have to make a similar change there. All right, I've opened the files in Fusion and let me walk you through what changes I'm going to make. For the big piece, I don't think there's a whole lot to be modified here other than the fact that I need bigger slots for the magnets. And I need the whole part to be a little bit bigger so I can screw it down to the underside of my desktop. But other than those two things, I don't think there's a lot. For the smaller piece, I'm going to make adjustments to the slot size to account for larger magnets, like I'm going to for the other one, and move this cutout to the bottom of the piece, like I said. And I have an idea of making this piece a lot taller than it is right now, maybe twice as tall or even 3 times. And the reason for that is because there's a quite substantial bend coming from where the magnets are down to the hole in the center. And there's not a whole lot of support down here. So it's almost like building the strain relief into the connector itself. Okay, let me take a few minutes. I'll be right back. All right, here we are. I spent more than a few minutes. It was closer to half an hour. But in any case, the first iteration is done. Let's have a look. So the female piece is looking like this. It's a little bit taller than it used to be, and it's got this wing sort of design. And that's primarily for the screw holes. Also, this is not the part that's going on the vest. This is just staying on the underside of the desk. So it doesn't necessarily need to be compact. So if we have a look on the inside, honestly, not much to see. The magnet slots are a little bit bigger than before, and the hole is still there. So yeah, not much changed for this one. Moving on to the smaller piece, when we take a look at the outer profile, it ended up being about twice as tall. I guess I could have made it a little bit taller too, but we'll give this one a try. And the space for the magnets is a little bit bigger. And when I say bigger, it's a little bit deeper. The diameter is the same as what was in the original model, so I've only made it a little bit deeper. Oh, and I'd like to make a small comment about the hole size on this male piece. It's pretty big relative to the rest of the parts on this piece. It's 6 millimeters across and 3 millimeters this way. And the reason for that is because we have a pair of 16 gauge wire going into the connector. I think an 18 gauge with a relatively thin sheathing would have been the best for this application, but I don't have one on hand right now, so 16 will do. Okay, I think that's enough talking, so let's get them printed and test them out. All right, the print is done. There are some minor imperfections on the outside, mainly because I forgot to calibrate the filament, but that's not something I care about. That's fine. One thing I do care about is how the magnets fit. It's good on that side. It's a little loose, but with a little bit of CA glue, that's going to be fine. And the opposite side, I suspect it's going to be a little snug because that's where the seam line is. So yeah, that's a little snug. I'm not going to press it all the way in because I won't be able to get it out, but that's a nice fit. So that's all good, but I've discovered one problem, and that is the wire gauge. This USB connector that I have has what appears to be a 22 gauge wire. Same thing for the DC adapter. That's 22, I think. And I've designed all my pieces to use this 16 gauge speaker wire. The main reason I wanted my wires in 16 gauge is because I didn't want them getting too hot. But then if all the other components are 22 gauge, is there a point in using 16? I think the current draw for this application is around 1.5 to 2 amps. What do you think? Would you use a 16 gauge or you're fine with 22? In the meantime though, I'll set up everything in 22 gauge wire just to see how hot it gets, and if it's fine, I'll keep it. If not, we'll come up with something different. Okay, I put it together and have been running it for a couple of hours now. And I'm happy to report there's no concerning levels of heat coming from the wires. The wires are hotter than the ambient temperature, and the ambient here is about 14 degrees Celsius. Unfortunately, I don't have a good way to measure the temperature of a thin object like this, but just by touching it, I want to say this is about 20 degrees Celsius. What is considerably hotter than the ambient is this power supply. I want to say this is about 40 or maybe 45 at the most. But I'll say that's pretty normal for a power supply like this. While we're on the topic of the power supply, it does make some noise when I put my ear up to it, but the noise is not one of those high frequency noises. And once it's mounted to the underside of my desk, I don't think I'll be able to hear it. I soldered the wires directly onto these magnets, and after soldering, they usually lose a bit of strength, but as you can see, they're retaining a fair bit of strength, so that's good. So yeah, I think I'm going to call this project done. It's not the most pretty finish in the world, but it's something I needed to get done to be able to work in the basement. I want to thank you for watching, and I'll see you next time. Bye.